All right. In this video, we'll be going over how to actually calculate descriptive statistics in R. So the data that we'll be working with is sort of simulated data based on a teaching method experiment. Which method works better? Where we have an ID number, sort of a nominal variable identifying each participant. The teaching method as either old or new, biological sex corresponding to male or female, scores on a pretest, and then scores on a post-test. So if we were to create a script to get us our different descriptive statistics, one thing that's going to be very helpful is if you save everything to an R object such that you can look up these values again and again and again, you can actually save. Another thing that's going to be very useful is if you use a placeholder variable such that you don't have to type out the full variable name every time you want to calculate a different descriptive statistic. So to start that off, let's say we're going to have a placeholder variable called pH. Let's say we want to actually look at this pretest score for descriptive statistics. So when we run that line of code, it actually creates a second variable over here that essentially just duplicates the teaching method experiment data's pretest score. So now we can actually go through and calculate all those descriptive statistics on pH. And if we want to do this for another variable, all we have to do is actually change what variable we're setting pH equal to. So if we sort of create this little descriptives variable right here, we can actually go about saving all the descriptive statistics we want. If what we want happens to be the mean, the function for that is just mean, and then we can go ahead and use our pH there, median, standard deviation, and there are no built-in functions for the range. However, it's really just the maximum value minus the minimum value. There's also no built-in function for interquartile range, or the 75th percentile or quantile minus the 25th. However, we can actually look up those quantiles individually. So 75th quantile minus the 25th quantile. So this will actually end up saving all of our descriptive statistics to this variable right here. So if we were to print this out, we could see them all. Now, one thing that would be nice is if we have names corresponding to what each of these numbers actually is so that we can see this in the future. We can do this with the names function, where we specify the R object we'd like to have names for, and then we specify the names. Now, in this case, I'm going to use the APA abbreviations wherever possible. So we want our first value is the mean, then we would have our median, our standard deviation, our range, which there's not an APA abbreviation for, and then our interquartile range. So now, if we were to print that out again, now we have names letting us know, hey, this first value is the mean, the second value is the median, standard deviation range, and interquartile range. Now, what we'll eventually want to do is resave this data that's in descriptive pH into a new R object that's unique to the variable that we're actually looking at here. So here's how we can go about doing that. Really, it's just a simple matter of creating a new R object and then setting it equal to descriptive pH. And then we can print out that if we wanted to. And now we have this new data here. It's just that if we wanted to then come up and do our post-test scores, all we have to do is select our post-test, come down here and change this to post-test. And we can rerun everything real quickly. And of course, I have a slight error because there's no capital T there. All right, and there we have our new data, okay, where we have our mean, our median, our standard deviation range, and our interquartile range. And as you can see over here, it's actually saved as a different our objects, where we have our pre-test descriptives and our post-test descriptives with those individual values saved.